website. You can go to the website and it'll do the same thing. And under version, you can put these in parallel next to each other, and you'll see some very, very different versions. And especially when you look at some of the Old Testament books, especially the prophetic books, look at a modern Jewish Hebrew to English interpretation and the one that you'll likely have in your Bible, and you'll read the same verse and say, do I have the chapter wrong? Do I have the book wrong? What happened here? And there's a lot of interpretation that goes into translation too. So I throw all that out there just to say it's good to keep a sense of proportion and to understand that we're all coming at the problem with some level of bias. All right, we always say that. Okay, first on the question of why do we want to know? That's a question. Let me ask you, why, for those who are interested, and more than a third, I think more than half the class voted for this as like the next topic they wanted to hear. Why is it important to you to hear this one? This is not a trick question, by the way. There's not a wrong answer that if you say it, I'm going to be like, aha, see? This is where you're doing the wrong thing. I don't mean that. But why is it important to you?
Because it gets asked.
Okay.
To us a lot.
Right. So under one, others, and that could be people who are interested in Christianity, ask a lot. And why? What do you mean specifically by that? Why do they ask? Yeah. To some people, if people in the modern secular scientific community, or even just the modern secular community, will look at Christians who believe, young Earth creationist Christians who believe in a literal 6,000 year old Earth, and they'll say, hey, that's one step away from being a flat earther. Or that's one step away from being a conspiracy theorist. That sounds crazy to me. Everything I've been taught since grade school has said the Earth is 4.6 billion years old, the universe is 13.7 billion years old, or 14, or whatever it was you were taught at the time. And so to believe this other stuff is weird. Are you a member of a cult? What other crazy things do you believe? That kind of thing. So yes, that's exactly right. Others are going to ask this question, so it's wise to at least know why they're asking it and have some information on it.
I personally want to discuss it because I think everyone views science or religion as mutually exclusive, and I don't think they are.
All right. There is a feeling out there, and it is extremely pervasive on the popular level, we'll say non-overlapping magisteria. There is a thought out there, and today I would say it's principally based in the secular community that says religious thought and belief is in some ways the intellectual opposite of scientific thought and belief. That these are two completely different ways of looking at the world, and that the scientific way of looking at the world is better. It's better for, and then they'll list the reasons that it's better. Savvy theists and Christians will turn around and say, no, they are both, there's a clip, and I used to show it in here. It probably won't play loud enough over here to see it. And John Lennox is the guy making the point, and his Irish accent's a little hard for some Americans to parse quickly, especially if you can't hear it well. But he's debating Richard Dawkins. And this was back 10 years ago when Dawkins was at the apex of his influence. And Dawkins says something along the lines of, you only have to believe something if you don't have any evidence for it. You only need faith if you don't have any evidence for it. And that's what he says. And so, before we get to John Lennox's answer, note that that's what a lot of the secular folks believe, and Christians believe, by the way. They're not restricted to the secular. Is that faith is to say, I see evidence out there, or I see data out there, but I'm going to ignore that, and I'm going to believe this anyway. Or alternately, there's no evidence out there for it, but I've been told that that's the way it is, and so I'm going to believe it regardless of the fact that I have no supporting evidence. That's what most people think faith is. We've gone to great pains in this class to say, we think that that's absolutely not the way that it is, nor the way that it should be. And so if your faith is based in, I don't have any evidence for it, but I'm going to believe it anyway, then by all means, that's a wishy-washy faith, and you should not have that. There are really, really good reasons for believing the truths of Christianity that are evidence-based, that are logically derivable. And your faith ought to be based on that, not based on I was told this and therefore I believe it kind of stuff. Yes, sir.
Well, when you look at the practical aspects of this, if you have ever attended a fundamentalist church and you listen to the pulpit,
Right.
and they say, the only science I need is right here, then you know.
So this point is exactly right, and this was the other.
Understand that, but that's the point that you hear in the popular press.
Yes, and my point that I was.
10% say that's the way all Christians.
The half, I would have said, hey, the fact that the secularist, that Richard Dawkins says this and believes it, just means he doesn't know Christianity very well. But I don't think so. I think the reason that that is the case has more to do with Christians who have done this kind of stuff, who have said, make these kinds of points. And that is not helpful to the reputation of Christianity, so to speak. People are absolutely floored. An exercise for you if you wish to do it now or sometime this week. Google Christian thinkers in science. And I think one of the front page things that comes up is the Wikipedia, who's not necessarily a fairly supportive of the Christian worldview as a whole set of pages, but Wikipedia lists all of these people who are both not just theists and scientists, but they go through all the greats of Galileo, Newton, and all these folks who the founder of the scientific method, literally the guy that wrote the scientific method was a Christian. So this idea that Christians are thought is antithetical to scientific thought stands at a minimum debunked by the idea that the guy that invented the scientific method or codified the scientific method was a Christian. And in any case, it's certainly not true, but it gets said by enough people that when you can't fault Richard Dawkins for thinking that, because people do say that to him all the time. When they lose the argument, instead of saying, you know what, that's a great point, I don't have a good answer for that. Now let me go back and research it, may I get back to you later, and if I find out that I was wrong, I'll come and apologize. If I find out there was data I was missing, let me come and bring that up to you again. Almost nobody does that. What we do instead is just say, well, that's what you have to say, I still believe this because that's what God says. If you know that God says that.
Bible said it, I believe it.
Right. Now, the problem is it's a problem of interpretation. And by the way, this is not a new debate. This, to get spoiler alert on the young earth and old stuff, but old earth creationism has been around for centuries, millennia. And old Jewish thinkers have thought that the earth was older than 6,000 years. Augustine, who is at a minimum a key influencer in the Protestant and Catholic churches, on whom a lot of doctrine, Christian doctrine was developed or written, he scoffs at the idea of young earth creationism. Now, there are other guys also of his level of influence that scoff at the idea of ancient earth as whatever. So the bottom line is there's enough material on both sides that even greats of doctrine in the church have held completely opposite positions on this one for millennia. This is not a new debate. This is not something that arose as a reaction to discoveries of science or to new hypotheses or theories that came out or to new innovations in theology. This is an ancient debate. Okay, I went way over time. Why else do we care? Why else do we want to know? Are science and religion non-overlapping magisteria? Are they mutually exclusive? What else? Yes, sir.
Is it required for salvation?
Ah, is it a core Christian doctrine?
Is there a certain way you have to believe?
Yes, right. Definitely. In fact, that bridges a little bit into question 2. So we'll say 1 and 2 both point to that question. Yep. What else? Any other reasons? Yes, sir. Ah.
People are interested to know if there's any contradictions in the Bible or mistakes.
It could be a great test of whether things that are in the Bible are true. So if the Bible has to bend over backwards to accommodate stuff that we found out to be undeniably true today, that's data that suggests that either the Bible or portions of the Bible might not be true. In fact, you'll see Christians use this as ways to debate other theists, like Muslims. They'll say, here in the Quran, it talks about Alexander the Great going and finding the place far in the east where the sun sets, and it sets in a muddy pool of water, and et cetera, et cetera. And here, that is good evidence that the Quran is not true because we know that that's not the case. So the Christian can't, in the one hand, criticize another religion's holy texts by saying, you see, they're scientifically invalid, and we know that to be the case, and then say on the other side, well, but I'm not going to subject my own books to that scrutiny. You don't get to do both. You can do one or the other, but you can't do both. Peter's absolutely right about that. Any last? Yes, ma'am.
Am I going to be accountable someday?
Okay, and
Because I think about how man does what is right in his own eyes. I mean, everybody seems to grow up in different paths, and look all around the world and the types of governments they live under, and the type of scrutiny they live under, the type of abuse they live under. Everybody seems to have their own ideas of what is right and what is wrong.
yes, a great question. Will I be accountable someday? And I don't know if you meant to imply this in here, but certainly contained in what you said was at least a hint towards the idea that your scientific beliefs and your philosophy do lead to what behaviors you choose to adopt. Now, I say this, but I should probably say, I'm the most pro-American person I know, right? I've dedicated my life to the defense of America. I went to an American university that was a service university. I was a Marine. I have done nothing but work for the government for my entire life. I am as pro-American as you can get. That doesn't mean that I think that everything we've ever done in America is spot on and wow, we haven't made any mistakes since 1776 or 1775 when the Marine Corps was founded, which is when the first right thing was done on behalf of America. Right. Yeah, it was also founded in a bar, so so it goes. The amazingly evil angel of death of Auschwitz, Joseph Mengele, do you know where he did his training? Where he learned about modern practice of eugenics? California. California was leading the way globally prior to World War II in eugenics. We had somewhere between 20 and 60,000 people that we had involuntarily sterilized. People in America, the mobile gas chambers were actually built in America originally. There's data on both sides out here, and so don't take my word for it kind of thing. But what I'm saying is we tend to put this like, oh wow, we've decided there's portions of the population that are unsavory or aren't good for breeding the populace, that kind of thing. So, but that was just the Nazis that did that. It was not just the Nazis that did that. There were a lot of people that were thinking about doing that, including America. And when Hitler, in his speeches, quotes sources that are American on eugenics, not a lot of it, but some of his argumentation was done based on the Carnegie Institute and the Rockefeller Institute's investment in eugenics and some of the things that the eugenicists in America were looking at. Now, eugenics became extremely unpopular in America after World War II, partly because, for the good reason of the people who were thinking about it said, wow, that could be a logical outworking of what we're thinking. Perhaps what we're thinking is not a good idea. But that's my point is, if you don't think through your system all the way to its logical extreme or to what people will likely think of it eventually, you could end up find yourself in the uncomfortable situation that you are backing a set of ideas and ideology that at its logical extreme do horrific things. So yes, that's just a little downer for you on Super Bowl Sunday. Anything else on that question? All right, so how much does it matter to the Christian? That kind of blends in with number one. But before I get to number three, which is the gotcha that I have you for, that it should at least make you think on the axiom side a little bit more, and that's not a gotcha. I am basically planning on doing all of this in one class, and then we use the rest classes to expand. So I'm going to make at least the thesis point of how I think we ought to think about this question all today, and then we can spend the next times asking individual questions of high interest to members of the class with an appropriate level of skepticism towards whether we can complete that. He's smiling only because we've said this several times, and in exactly 0 of the cases have we pulled it off. But maybe this will be the first, you never know.
No one stopped coming.
That's right, not yet. Or maybe that's not an important thing, so I'm going with that. Okay, data. What are the data on both sides? Now here's the downside. There is a lot of data on all sides of this, and let me at least divide it into 3 possible hypotheses. These are not the only 3. There are lots of others, but all of them, to my mind, fit as sub-hypotheses under these. One is that the Earth and the universe are very old, and God was not, we'll say, specially involved. And specially involved means, I'm going to say post Big Bang. Okay, so, and we'll say that's the next one is Earth is old. We'll say God is active. And by active in there, we mean specially active. And the other one is Earth is young, in which case God is, obviously, it implies God is, and I mean by that Earth and universe are young, and that God is active as well. And active, but meaning specially active, like stuff like there was dirt, and then God formed a man out of that dirt and said go, and so there was no evolutionary prehistory to that man, that kind of thing. So that's a young Earth creation. There's an old Earth version of that one where the Earth is really old and then God airdrops man into that one as well. There's another old Earth creation where all of this evolutionary process that brings man to the fore is manipulated by God specially and miraculously in the way. And then there's the other one that says the Earth is just, God kicked it all off at the Big Bang and basically programmed the vectors of the atoms in the Big Bang in such a way that all of this would result. Now, of course, this set of things is just potential Christian belief. There lies outside of that one the normal secular belief, which is we don't know where it all came from, but it did start in a Big Bang and all of it proceeded deterministically from that point. Or if they say non-deterministically, they don't mean that God or something else was interfering with it. When they say non-deterministic, they mean some sort of quantum uncertainty from an interpretation that says that these non-deterministic acausal or unknown cause type of events occur. So within the set of kind of Christian beliefs, that represents at least the majority of the spectrum that's out there. And so most people really want to know maybe only two of those. Is the Earth old or is the Earth young? I'd say really that's the number one question that most people want to ask. And that this set over here, this subset of the Earth is old and God did it at the Big Bang, or the Earth is old and God's been messing around with it, they're really two halves of the same coin, or two parts, two views of the same general idea.
So you're really starting with the premise that there is a God creation.
I'm starting with that premise because the question was asked in a Christian framework. If the question had been asked by Dennis or somebody else that was not a Christian, I would have said, let's include in the set, there ain't no God. But then I would start that one with the arguments that we've made in this class before, which is there has to be a timeless, spaceless, immaterial, enormously powerful, personal creator of the universe. And so all the arguments that we've made before there, that's where you start that set of argument. But the Christian assumes this kind of from the beginning. So if you start with that assumption, then this is the set you look at.
So if you're starting with that assumption, is it really a question of interpretation of Scripture?
It's certainly the case that if we believe that Scripture is
Timeline and level of involvement.
yes, and if we believe that Scripture intends to communicate specific truths about, time and method and all that kind of stuff, which it seems like it does, right? We've got 2 creation accounts. You've got 3 creation accounts when you count Job. You've got 3 different, not different, but three separate accounts of creation. And they don't necessarily match exactly one for one. It's not like you can lay each of the features of the Genesis 1 and 2 account right directly over the Genesis 3 account and say, these, each one of these properties matches up exactly. And Job actually has the most information on creation of any book of the Bible, at least by weight, so to speak. If you cut out the verses and weighed them, there's more on creation in Job than there is in Genesis. So that kind of stuff. But yeah, that's right. Okay, so if these are the things that we're looking at, let's talk a little bit about some of there's a bunch of evidence on either side, but let me talk briefly on axioms. And let me talk about what are the most compelling evidence on each of these, or at least some of the most compelling evidence to me. On the axiom side, it is the case you'll hear creationists, especially young Earth creationists, break things down into something like uniformitarianism is a term they like to use, and gradualism. And on the other side, especially on the young Earth side, it's catastrophism or something like that, where there's the idea of rapid onset. And so you'll see this, these types of things broken out frequently on things like the Grand Canyon. Someone will, on the uniformitarianism or gradualism side, will say it takes millennia and millennia and millennia to form the features that you see in the Grand Canyon. We know this because here are the geological processes, et cetera. On the other side, you'll have the catastrophists say, here's Mount St. You said all these layers only form under certain conditions that take years and years and years to do so. Here's Mount St. Helens. It formed, several thousand layers of dirt in a couple years time frame. And so your assumption is false. And so it could be that these are not signs of old, these are signs of young, that kind of thing. So I will say that you'll hear the young Earth folks say things like they use the fossils to date the soil levels, and then they use the soil levels to make the argument that the fossils are old and that there's a circular reasoning in there. That's partly true. It is true that they tend to date layers based on stuff that they find in those layers. And then they turn around and say, because this layer is this, then these layers are younger, and here's how it works. Unless we find these old fossils above them, in which case it was an inversion of layers that must have occurred. And the younger creationist says, well, that's not fair, you're cheating. And the old one says, you're not even thinking about it. You can see that these are distended, that kind of stuff. So these arguments go back and forth. The referee in these arguments has typically been radiometric dating. There are a few forms of radiometric dating, but radiometric dating is fairly simple. You've got, you go and dig in your dirt or in your bones or your bones that used to be, or stone that used to be bones or whatever else, and you find, atoms A and atoms B. And atoms B are some sort of isotope or something like that of atom A. And so there's a ratio of A to B in there. And if you can make an assumption of how much A prime there was originally, and A prime decays over time because of the known processes of radiation into these daughter particles. So if it's the case that you know how much A prime you have, and you can measure how much A and B you have in a ratio, and you know the formula that tells you how quickly that stuff turns from A prime into A and B, now you can date it. And so all the argumentation that goes on has basically to do with contamination and a little bit of whether this process of radiation has changed over time. But ultimately, a lot of it has to do with people saying you can't know how much was originally present in the first place. And so you'll see things like some people will say, and I'll get to the questions right after this sentence, some people will say, look, this soil dates to 60 million years old. We know that because we know the A and B stuff. And then other folks will say, well, look, we watched the eruption at Hualalai in a volcano in Hawaii, and when we sampled that soil and subjected it to the same process, it told us that that was a 2 million year old eruption, or in some places that was a 200 million year old eruption. So we know for a fact that that doesn't work because it doesn't work here. And then the counter argument is, well, those are probably fairly likely contaminated because they were so close to the surface. And then someone says, no, it's not the case. And they go back and forth and back and forth and back and forth. So the problem is there's a very simple process out there that nobody disagrees with. If you have this much material, it decays at this rate into these two bits of material. If you know all three of those, you can get the date, the time. Or if you know the time, you can infer what the relationship's going to be. It's all the argument has to do with contamination and ratios that are in there.
I think the problem is the longer you want to say the Earth has been around, the more time and opportunity there is for contamination.
Yes, and that's a, so I'll give a compelling kind of gotcha that the creationists used, and then I'll use another one back against the young Earth creationists as well. I'm trying to talk about this objectively as though I don't have an opinion here. Of course I have an opinion, but I'm trying not to let it, as much as I can, influence the delivery. Example, you've got T-Rex, 60-ish million, 60+ million years old. That was the period in which we believe that a lot of folks believe that they existed. And so people will say stuff like, well, we find fossils of these kinds of things. We can only do these 4 versions of radiometric dating in here because we can't carbon date them because there's not all the carbon 14 atoms would have degraded by 10 times shorter than that. So we're only ever going to find these bones. We're never going to find any good material. So the Jurassic Park, the mosquito bit the T-Rex and then he got trapped in amber and then that got preserved. Nobody thought that was a possibility because even if you trapped a mosquito in amber, you would expect DNA and all these other things to break down to such a degree over 69 million years that it wouldn't be anything usable in there. Then this Mary Schweitzer goes and is going to move. She's working interestingly with the guy who's actually the model for the Jurassic Park dude with the hat, the paleontologist in Jurassic Park. He was the model for that guy. She's working with him. They find a female T-Rex bone sticking out of a cliff, and they can't get it down because it's so heavy. And so they make the call, we're going to cut it in half. They cut it in half to again put it together, and they find inside squishy material. And they were wondering what this was, so Schweitzer runs some tests on it, dissolves the remainder of the bone with acid, and she gets this rubbery material in here. And without walking you through the whole thing, the bottom line is they find soft tissue in there, including blood vessels, red blood cells, that kind of stuff. Had you asked people, generally speaking, the scientific community that works in here 10 years prior, if you found soft tissue inside of what type of evidence would be acceptable that dinosaurs are not as ancient as we think they are? And they said, well, I don't really know. And you said, well, if we found soft tissue of a 69 million year old or a 70 million year old or a 200 million year old animal, wouldn't that suggest that maybe it's not 70 million years old? And they'd say, yeah, probably. That would be a good disconfirmation. So Schweitzer, who, by the way, is not a young Earth creationist, in fact, maybe isn't really a creationist at all, is very much in the secular vein, was absolutely attacked overnight by people saying, you screwed up the science, this was shoddy workmanship, this was contamination, all kinds of stuff. This can't possibly be soft tissue. There's no way. Several years go by of testing, and she's like, look, come do this stuff. Don't take my word for it. Do the experiment yourself. And a lot of people did, and they found more and more and more of the soft tissue. Now, the young Earth creationists immediately proclaimed victory. Hey, there's your smoking gun. These things aren't 69 million years old. They're not 70 million years old. They're not 200 million years old. Your clocks are wrong. What do you think the opposite side said? Yeah, we just didn't understand how it is. It turns out that if you put it in an iron-rich environment, which maybe the blood would create this iron-rich environment, maybe this stuff will be preserved way, way, way longer than we ever expected. And that's the current view now is, if you go look it up, if you looked up the pages from decades ago, not that there are many of those on the internet anymore, but if you looked up the information from decades ago, the data said these types of biological materials only last for 100,000 years, 200,000 years maximum, theoretically speaking. Now, the same, so to speak, sources say, in the right conditions, this material can be preserved for hundreds of millions of years. So the problem with this, and there are other versions of this one, mostly have to do with astronomical observations, that the young Earth creationists say, well, the following would be a disconfirmation, and then that information shows up, and they're like, well, it's not really a disconfirmation. Here's the way that you can account for it. This is not just a religious debate, by the way. So that behavior, I mean to say, where you say, yep, if I saw evidence A, that would disconfirm my theory. When evidence A actually shows up, very few people abandon their theory that they've been working on. And that's not religion and non-religion. That's not Christian scientists who are Christian or theist and scientists who are secular or atheist. That just doesn't occur there. Go back for fun sometime if you want and watch the debate between the Big Bang guys and the steady state universe guys. So in Einstein's time, the overarching belief, almost complete in science and physics and cosmology, was that the universe was in a steady state, and that steady state looked a certain way. It wasn't until Hubble makes some observations where he's like, hey, did we say something wrong? It looks like the whole universe is redshifted. It looks like everything's running away from us. How would that be the case? And Hubble comes up with two conclusions. He says one of them is too hideous to comprehend, but that the other one is that space looks the same from every point. Now, the too hideous to comprehend, anybody know what that was? That we would be at the center of the universe. And he found that he's like, that can't be the case, because now we're back to Copernicus, and that can't, so since that's not right, the whole universe must look the same. And all of modern cosmology that you see right now is the child of the debate between steady state universe guys, and there's still some of those alive today, very few of them, most of them are fairly old physicists, and the people who think that the Big Bang is the way that things came about. But this is 100 years old. Prior to that one, it was a completely different, and the Big Bang is a pejorative name that Fred Hoyle and his crew gave to these young whippersnapper knuckleheads that thought that the universe just popped into existence in this Big Bang kind of idea. So that scientific name we used was an insult that one side used to point at the other. And that wasn't a religious debate. That was a purely scientific, nobody had any preconceptions that were religiously based that were informing their decisions, at least on a large level there. Okay. So I say that now, maybe a ding on the young Earth side, because some of that evidence, maybe that says we should be considering the young Earth side a little bit more.
The top left one, is that, would you say, more of a result of Concordism?
Sure, yeah. Maybe you could say this, or certainly this, right? So maybe this has been existent for a while as well. But if you add that last sentence in there, then yes, that was more like, okay, there was a Big Bang. Now, how do we understand biblical text in light of that? Yes, that's right. On the young Earth side, again, back to Einstein's time, don't forget how young all of our modern scientific theories are. They are not, we act like we've just built this thing over millennia and we stand on the top of this scientific edifice. That's not how science works. Science gets continually knocked down and rebuilt, and continually knocked down and rebuilt, and continually knocked down and rebuilt. And we'll use little bricks from stuff that we used before, but it is not this edifice of great height that we built over time. Our technology tends to make us think that, but that's not how the theoretical science actually goes. In Einstein's time, they thought that the universe was the galaxy. They thought our galaxy was all that there was in the universe, so that the universe was something like 100,000 light years across, something of that size. Then they start pointing these increasingly powerful telescopes and radio telescopes at other objects that they used to call quasars. You've heard this out there, quasars. They found out that most of these quasars, or many things that they thought were quasars, were in fact not quasi-stellar objects. They were whole other galaxies. And then so they were like, whoa, hang on, it's not 100,000. And then, by the way, thought it was a steady state. Einstein's equations that he wrote, his general relativity equations, were meant to work in a universe that was basically spherical or at least flat spatially, and of a limited size, and it's balanced on this knife point, not expanding, not contracting. It's balanced. And in order to make it balanced, he had to add in something called the cosmological constant. So he does all these equations, and his equations would mean that it all collapses in on itself. And so he has to have a positive force that's pushing it all apart so it doesn't all collapse in together. And so he adds this symbol in there, and this symbol in there, and he puts that symbol in there and says, this is a cosmological constant. And he later called it the biggest mistake of his career. Now, as it turns out, the cosmological constant has reared its head again. And if you've heard of dark energy, that's the cosmological constant nowadays. People say his equations were right, the cosmological constant does have this value, and it is dark energy. Now, what is dark energy? And we don't know. But the bottom line is they say the universe, so they measure these galaxies that are moving away, at least by redshift, and they say the measurements we made 10 years ago, or measurements made 5 years ago, showed a lower rate of recession than we see today. Inference, they're accelerating away from us, which means that this positive pressure is increasing over time or something like that. And so this is a big deal nowadays, and a lot of research and money going into that kind of stuff.
One of those, when you were talking about catastrophism, the last time I heard that term was in college when we did the history of geography. Apparently I was told that was the prevailing thought. It wasn't a new thing that we created, as far as I understand. It was like a way of thinking, maybe in contrast when they had to look at something.
So it's really hard to trace the history of a thought. You know, the history of an idea is hard to trace. But to your point, Steve, it used to be you have these guys that believe that basically there was a flood. Everybody talks about, these are antediluvian animals and that stuff. If you've read any of the books that were written 200 years ago, they talk about the antediluvian even in the secular literature, as though that were a thing, that everybody assumes that's the case. Then this uniformitarianism, gradualism idea arose. Then the catastrophists, this is my opinion, who knows? I'm not enough informed on this to claim that this is the way it is. But it seems like they go putting a bunch of evidence in there that was like, no, here are signs of how this was catastrophically done. And a lot of the evidence that people looked for to establish uniformitarianism assumptions turned out to be the opposite of what they were looking for. And there's a lot of math out there that suggests that the pure uniformitarian gradual approach can't be right. A whole bunch of reasons. You'll find dozens of them out there that are open mysteries for the uniformitarian, but the catastrophist is like, no, I can tell you how that happened, something like this. So the fact that catastrophism re-entered mainstream secular geology was, in my opinion, as a result of the normal secular uniformitarianism ideas bumping up against, in some cases, religiously derived catastrophist ideas. And so other people were like, yeah, there were some catastrophes, and this is how it happened, and it doesn't take a global flood in order to do so. Yep.
There's if you haven't read it or heard about it, I'm piecing my way through it, but it's a book by a guy named Thomas Kuhn.
Yep.
And he wrote The Structures of Scientific Revolutions. And he just basically, his main thing is that normal science is going through and confirming what we already know and accumulating enough anomalies that at some point somebody says, oh, maybe we got it wrong, or maybe there's something else going on here. And then that's what he writes about, basically. It's the fact that, hey, now we're going to change what we think to try to accept, because our natural inclination is to just brush off the anomalies as being anomalies. And I just thought that was interesting. But he goes back through history and kind of just...
Yeah, and I think Kuhn adds to that, and I could be wrong because I'm only slightly familiar with his work. He adds to that not just, so you build this theory and then it collapses under its own weight. What actually happens is you build this theory, it gets really, really heavy, so to speak. And so other people develop other hypotheses and theories to say, well, maybe it's not that, maybe it's this. And eventually, when you build this well enough to explain the anomalies of that, or where people look at this other explanation and fresh, and they say, I like the new one versus the old one, that's when the old one starts to get abandoned and the new one starts to show up. But the idea of like, overnight, this thing just collapses of its own weight, if he makes that point, I think he's wrong. I think, generally speaking, I use, what did we call the scientific belief that there was contained within any material, phlogiston. Phlogiston is the flammable material in anything like wood or metal or something. And when you light wood on fire, it releases phlogiston. And so you can take wood, and a log of wood, and weigh it. And then you burn it and you weigh the ashes, and now you can calculate how much phlogiston was in it. So this was the phlogiston theory. And this was popular up until maybe a couple hundred years ago. And it had some anomalies in it, which was when you burn metal, it got heavier. It was like, well, what's going on there? The metal was clearly burning, and yet now it weighs more than it did beforehand. And there was some shrugging and some hand waving, and maybe it's this kind of stuff. And then a new theory of thermodynamics shows up that talks about what heat is and what burning is, and that seems to be have greater explanatory power than this other one does, and so this one dies the death and this one rises. But it wasn't overnight. The same way that Big Bang Theory, which is now maybe Lambda CDM version of the Big Bang or something like that, is the most prevalent modern theory of Big Bang, there are still adherents to steady state theory. And by the way, steady state guys think that new material is being created all the time. So they go look at galaxies out there, and they submit as evidence that here are new objects coming into existence in the middle of these galaxies as they're getting sucked into existence. So steady state theory thinks that you're constantly adding matter to the universe by some process we have no idea. And they still make arguments for this stuff today. You can find this on YouTube. There's still people arguing. This may have died out in the last 10 years, but at least up to 10 years ago, people were arguing that the steady state model still could be true. So they don't die. If Kuhn makes that point, I disagree with him that they die overnight. But
It's more the looking at how we think about it.
mm-hmm.
In other words, that there may be a prevailing theory that people have been discussing and saying, never mind because it doesn't fit. They won't give that new thought the time of day until So not that it wasn't there, or something that really kind of changes and people say, okay, now really.
Yeah, and then I would say,
But I have to, that was my impression, and then I'm going.
yeah, and let's say that's right. Back in generally the model looks like this to me. People believe in theory A, and then let's say that's the majority. So I should have made this box really, really big. And these are the people who believed in theory A for a long time. And by the way, they're old guys and gals. You know, these are 50, 60, 70 years old. They own the university. They're the PhDs. They're the that are have been around for years and years and years. Whippersnappers come up with theory B. Theory B seems like it's better than theory A. But in the literature, theory B is rarely given any time because the literature is owned by these guys, or the power structures are owned by these guys, or whatever it is. When the new generation of C come up, and these are your young grad students and postdocs and doctorates that are getting minted, or scientists of various types, engineers, they get a fresh look at A and B. And if B is a better theory, what ends up happening is the ranks of the B folks end up getting swelled with the new people who are looking at it from a fresher perspective. This may not be correct, but this is what it looks like to me. And by the way, my wife has been embroiled in this kind of thing. She, as her doctoral thesis, did something on judgment and decision making in conjunction with some other PhDs. And the work was a criticism or a modification of a guy named Anderson's work on judgment and decision making, the model that he had. And what they said was his model doesn't explain certain features, so you need to modify his model, and now it explains all these features. And they submitted it to the journal, and the journal rejected it with like tons and tons of red criticism on there. Why? Why did the journal do so?
They were in A.
The journal, when a journal gets material, you know, and you're an editor of a journal, there's a million different parts of your discipline that you don't know that much about. So what you do is you send it out to referees. Referees are experts in the field that can comment on it. And guess who one of the referees for the journal was? Anderson. So of the 3 or 4 referees that were out there, 3 of them are like, seems legit. Anderson's like, no, this is wrong and here's why. And in his referee report, he made statements that were, I don't know, this is coming from my wife and therefore it's true, made statements that were like factually inaccurate about what they were saying and about their data. She then goes to an advisor, Dr. Rajmakers, and is like, you know, the team is upset. They're like, this isn't fair. Literally, the opponent is grading our test. That can't be the case. That's not how this works, right? How do we go about redoing it? And what was Rajmakers' solution to it? Here's how to modify it. Here's how to get in touch with Anderson. Submit it to a different journal. And they did, and it got published. So we like to say that, you know, the scientific literature, you know, it's objective. It doesn't. Nope, that's not how this works. That is a process made up by humans. It has the same difficulties that all power structures with human beings involved does. And so as a result, anytime somebody tells you this, I will put this out there. You guys have seen maybe the YouTube channel Veritasium or Veritaserum or what it is. Look up the one that says, is most published research wrong? Is most published research wrong? I won't say anything more about it, but this guy's not a Christian. This guy's not he's not a scientist, but he goes and asks all these scientists' opinions. Watch that video, and I think that'll be eye-opening to you. Peter and then Brian.
Should there be maybe a fourth option up there that's God created it, universe, but the Bible was intentionally ambiguous as to the timeline?
There could be, but if you're talking about these as de re, total structures that represent the objective truth of what happened, then whether the Bible was intended to communicate that truth or not is not relevant to that question. Now, if what you want to say is, well, should the Christian divide it into these, or should he be asking this question at all? She should be asking this question at all. All right, that would be right. But I'm assuming we've gone past that and instead said there was an actual creation or origin of the universe, and the Bible does say something about it. Therefore, I need to have an understanding of what the biblical, if it's the case that that A is true, how is it that the Bible is saying A? Or alternately, if the Bible very clearly says B is true, and scientists say A is true, then how are we supposed to deal with that? So that's really the question. I think that's where the conflict occurs.
Yeah, because scholars disagree on
Absolutely.
historical and poetic flow.
Absolutely. And so when we get into that, those type of things have to do with, is this core doctrine, will it be accountable for it someday? And when you ask the question, when you start getting into the question of, okay, what does, and we haven't yet, right? What does the Bible say about this? The question is, what is the Bible intending to say about this one? Is this supposed to be a scientific description? Is this supposed to be a poetic hyperbole? And you tend to see people adopt their views in the view of the evidence of modern science, rather than saying, forget modern scientific viewpoints. Let's instead look at what it would be most reasonable to conclude from this right here. Yes, Brian.
The overturning of old scientific theories, I think one of my favorite quotes about it is science advances one funeral at a time.
Yes, right. Yes, that's a great way of find who said that and post it on our page, because that's a fairly profound statement, if macabre. Yeah. Okay. So I want to throw. It wasn't intended to be a survey of all the stuff. Let me finish. On the younger side, the trouble of being here's this universe getting bigger and bigger and bigger is this. If the galaxy is 100,000 light years across, and I think everybody believes it's 100,000 light years across in size, why doesn't that imply, since we can see the other side of just our own galaxy, right? Forget the galaxies we can see that are further away than that. If our own galaxy is 100,000 light years across, then it takes 100,000 years for the light to get here. Then therefore, the universe at a minimum is at least 100,000 years old. Obvious, right? Now the younger side has a very some of them, not all of them, there's a very interesting subset of them that say it may be 100,000 light years across in size, unidirectionally, but that from the opposite direction, that's not how long light takes. So they have a model of the universe that basically says when light goes out, it takes so long. When light comes back, it takes a different amount of time. The speed of light depends on the direction it's moving in the universe. Now, there's head shaking in here, and this is not my favorite theory by a long shot. I don't back this one, but let me say the following. Special relativity and general relativity are based on an assumption. The assumption is that the speed of light from here to there is the same as the speed of light from here to here. It is literally impossible under the physics regimes that special relativity and general relativity use to test whether that's true. It is an axiom. It seems a reasonable axiom, but it absolutely cannot be tested. So when people say, well, science says the following, Einstein will tell you, is like, nope, this is an assumption, and it's completely unprovable. I like it because I don't have to explain a difference between the two. It seems simpler to me, but there's nothing in the world that says that's true. There's no way to test that. And if there is a way to test it, people have been thinking really, really hard for 100 years of how to test that, and nobody's come up with a way to test that yet. So maybe there's a way to do it, but we don't know. And it is just an assumption. So when the young Earth guy turns around and says, nah, one speed in one direction, another speed in another direction, it's hard to believe this, but it is the case. He's actually doing no more than Einstein did when it came to taking on assumptions. He's just saying maybe it's the case that this other way is the way that it works, and if so, these are the results you would see. So is that the best assumption to go with? I don't think so personally, but there's literally no way to prove that guy wrong. Can't be done, at least at that level.
There's another thing. In the beginning, God said, let there be light. Before he created the sources of those light.
Right.
Then he made the sun, and then he started to rule the light. So, if the light was here before the source of the light,
Right, and
you don't need the speed of light to, I mean, it's sort of conceptually, I don't get what I'm saying.
and so and there's a lot that one can do with that. So the young Earth creationist is going to say, this is evidence that only the miraculous makes any sense. Maybe some young Earth creationists might say that. Some guy who wants to co-opt Big Bang model into this thinking turns around and says, no, that makes all kinds of sense, because in the first moments of the universe, you got almost nothing but you got this phase where you don't have light running around, then you've got this phase that's extremely bright, and then you've got what they call the dark ages, this phase where the light is not being emitted like that, and these stars and whatever are being formed, and then that light comes back into existence as it's being emitted from the these stars that are now being formed and these nuclear fires that have lit off. So in the Big Bang Theory, you have early on light and then some darkness in some places, and then light again, more local, geographically local to these stars. Which, by the way, nobody's got yet an accurate, a theoretically possible model of how star formation can occur. So it's not. There are anybody on the younger side or the older side that was like, our theory's a lock, there are no holes in it, is not telling you the truth. Nobody's theory on any of these sides has a theory that is not as full of holes as Swiss cheese. None of them.
And that's because the record keeping back there just wasn't good at all.
That's true to some degree. But a lot of people will tell you, you can look at the record by looking far enough out into space with your telescope.
Weren't some ancient writings not intentionally not chronologically ordered?
Yes.
Is that
It depends on your hermeneutic for interpretation of Genesis. Yeah. So Peter's eager to get out of this and dive into the nuts and bolts of it, as he always is. But let me put that off for one more minute and finish this point and then take you to the assumptions point that I think is the last one that I intend to make anyway.
Scott, before you-
Yes, please, Al.
There is an explanation that was persuasive to me that I can look it up, but it's using the Einstein's theory of relativity.
No, don't go stealing my thunder yet, Al. That's point 3. Yeah, hang on. Hold on. And by the way, if you've got a pet theory out there, if you got something you want people to look at, that's why we have a Facebook page. It's not for me to make announcements about class. It's actually for discussion. So please put your stuff up there and have a look at it. All right. Here's what I want to say is that on both sides, you've got people who are having to bend the rules of physics in order to answer their questions. DNA won't last that long. We found DNA. Apparently it'll last that long. The universe is small. Nope, looks like it's really big. Light moves a lot faster in these regimes, you know. So there are people who are doing gymnastics to answer the new evidence that comes up. It's not like new scientific evidence comes up and the scientists, the atheistic scientists were right the whole time. Nor is it the case that new evidence is coming up and the theists are like, see, we told you so. It goes back and forth all the time. Okay. Now here's my favorite question to ask. It's this blank question. Creation, evolution, young earth and old. If something like relativity, general relativity is right, according to whom? Who has seen Interstellar in here? That movie really torques me off because it gives people a lot of bad ideas about general relativity. It can't possibly be true, not the least of which are these causal temporal loops. So you'll remember when, Matthew McConaughey is in the capsule with Anne Hathaway, and they're going through this wormhole to this place that has a black hole on the other side, and something weird happens, and she reaches up and touches this anomaly, and she says it's the first handshake. Well, that handshake you find out later is actually, spoiler alert, Matthew McConaughey coming back through this other weird spatiotemporal window to basically touch that ship again. And so she's touching his hand at a different point in time, space-time, but in time. The problem with that, and I'm not here to debunk Interstellar, but the atoms in McConaughey's hand that are there are also right here. So you violated the law of the conservation of matter and energy in order to make that movie work. So what I'm not saying is, as Interstellar says, so does the theory work. That is a violation of the laws of physics that we know here. That's not true. That can't be the case. Not without self-contradiction. I think I just lost the power on this thing because I failed to charge it properly. Imagine, there's a screen up here. We don't really need this for next. According to whom is the question. In that movie, again, in ways that don't make sense by the science, because there's a planet, it's close to this black hole, and if you're on the surface of the planet, time ticks at one rate. And the person who is in orbit, time ticks at a different rate. So for him, it was something like 1 hour on the face of the planet is 7 years for the guy in orbit. Never mind that if the black hole's over here and he goes into orbit, he's now closer to the black hole, which is more distant in space-time, which means it's now ticking slower for him than it is for the people on the planet. Apparently, we're going to ignore that. But they go down to this planet, they mess up something, they spend 2 hours on the planet or 3 hours on the planet, and he was like, I've been waiting for you for 23 years, where have you been? That kind of thing. It is the case that in a regime of general relativity, time ticks differently in different spots. So here on the surface of the Earth, if you watched your watch go around, it would go a certain way. If you went to the surface of the sun and you didn't burn up, you would turn around and watch your clock tick more slowly than the guy on Earth is watching his clock tick. And you wouldn't know that until you came back to Earth and you're like, hey, your watch is wrong. And he's like, no, your watch is wrong. Whose watch is right? And this is fairly well validated science. We correct our GPS satellite signals based on this assumption that in these gravitational wells, time ticks differently, and when you're moving a certain speed, time ticks differently. So this is not, I'd say there's really, 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 really good evidence that this is the case. So here's what that means. If you're starting the universe out in a Big Bang model where everything is concentrated in a singularity, and you expand it out, now let's say you got a universe the size of a grapefruit, and you had a watch ticking in there, and then you kind of pulled it out and set it outside the universe and said, all right, keep ticking at that rate, and you expand the universe out to whatever size it is now, and you take a watch ticking on Earth there, and you take it out of the universe and you set it next to each other, and you say, how fast are these ticking? The watch that you got from the Earth is doing this. And the watch from those first, that got yanked out at the universe is a grapefruit size, does this, tick, while this one's doing this. The quicker the universe expands, the faster time goes, so to speak. When you ask the question of, hey, I'm going to describe the universe to you from the beginning up until the point that you see it now, according to whose clock? So when modern cosmologists and physicists and astronomers and astrophysicists tell you that the universe is, I think the current estimate's like 13.7778 billion years old. When they say that number, do you know that that number is not according to the Earth, to time on the Earth? That number is not how old is the universe based on the Earth's surface. That number is how old is the universe relative to an observer who is stationary compared to the expansion of space itself. It's a uniform network of observers, you might think, and it's a cosmic time, you might say. And that time, that cosmic time, has been, quote unquote, speeding up over time. Now, that doesn't bend your brain enough. Let me put it to you this way. There's an MIT physicist, I'll put his paper out there, if this was some of what you were pointing at, Al, maybe. If I misunderstood you, I apologize. A Jewish fellow who is not a Christian, he's a Jew, and he was looking to also resolve some of these questions. And this is a MIT PhD. This is not some scrub that came up with a weird theory somewhere. And a professor at MIT, not just he got his PhD from MIT, he was a professor for years at MIT and other places. And he says, if you look at the universe, at some point, and I'm going to forget the number, but let's say it's like 10 to the negative 23 seconds, so just the infinitesimal slice of time, very early on. At some point, the universe is too hot for matter to even form. So like if you tried to make a proton in the Big Bang, if it's this big, it would instantly be ripped apart. You couldn't even get it together in the first place. At some point, the universe cools off enough where matter coalesces. So you start to get these subatomic particles first. And let's say that the first time that occurs, the first place that you get clumpy space that turns into matter, you get energy converts into matter at some point. That's actually the first point at which we know how to measure time. And some people, I disagree with them, but some physicists will say, well, at least for physical time, that might be the first point that you even have time, where time itself as a dimension rolls away from being rolled up into these spatial dimensions. If that sounds like nonsense to you, I happen to agree, but that's not my area necessarily. So at any rate, if you take that time of that marker in the universe of when did this matter first form, and you say, that's what I'm going to use, that's the clock I'm going to use. How old is the universe based on that one? Well, each time you double the size of the universe, you speed up the clock a certain amount, by a certain factor. And what it means is, if you look at the biblical days, and I'll let you look through this, I won't cover this in detail here, but if you look at the biblical days, up to day basically 5.5, and you use that as the clock. And then now that you've got man on the earth, you say, okay, I'm going to switch my time regime from here to now I'm using the watch on the earth. If you do that, if you say, this is the clock that I'm using, why am I using this clock? Because there's no sun. You know, like what does a year mean if there's no earth and sun for the, you know, that thing to go, that kind of stuff. If that's the clock that you use, and then this is the clock you use once you get man on the earth, do you know how old the earth is? How old the universe is? 6,000 years old. Now, not 6,000 years old according to the surface of the earth, but if you're watching the clock here and you're like, how many years ticked by the time you get day 5.5 of creation-related events, and he uses an evolutionary model through all this, by the time that you get man on the earth, that was 6,000 years according to this clock that you pulled out at that 10 to the negative 23 seconds and you set it off over here. So something like 5,500, 5,700 years have gone prior, including up till today, right? That's how the clock works. So it literally depends on where, and if somebody says, no, you guys are doing, he's doing acrobatics in order to make that happen, I ask you the question, if you're God and you're trying to tell people how old the earth is, which clock are you using? Do you use your watch and then you hand it to man? Do you say, well, I'll say it to him as though he were around the whole time, even though he weren't around the whole time, and that might confuse him when he gets to the point. How do you do the model? If you happen to know general relativity, this might be the model that makes the most sense. 6,000 years old. That's really weird if you think about it, but according to, if you imagine there was a black hole that formed right at the initial portion of the universe, and it stayed this really, really massive black hole, and the universe for us is 13 billion years old, if you were on this close, if you're on the close part of this radius of the black hole, or right on the part of the radius distance from this black hole, a certain point in there, you might say, if someone asked you, how old is the universe? You'd say, what are you talking about how old, man? It was created today. What are you talking about? At the particular part of that black hole, the universe is literally a day old. Not like in some way of thinking. If you had a clock sitting there, you would have less than 24 actual hours that ticked by, and all of the stuff that happened would have happened. So that's not theology, that's general relativity. So I throw that out to you just to say, there's a lot of people that want to turn around and put their finger down and say, this is the way that it is. And if you can ask them the question, according to whose clock, and they look at you puzzled, they haven't even thought through the issue that says, I'm arguing about the time in a place where I accept general relativity, and I don't even know what you're talking about. Okay, so they're making an argument out of ignorance, and that's on the religious side, that's on the atheistic side, and the scientists on all of them. If they're not thinking about that, they're not thinking about the issue.
The other thing that kind of piggybacks off this, and just blew my mind with that, but everyone thinks of time as like an absolute thing, right? So the only absolute I think that we can all agree on time is in one direction, right? So when you think about, I've got a 3-year-old, right? When he has a birthday and he turns 4, that 1 year was 25% of his life. That 1 year feels like a very long time.
Yes.
When I have a birthday, it's like 1/38 of my life. So as you get older, even though time is fixed, you're accelerating through time.
Everybody in the room, feel free to mentally curse him for this one, because I'm going to tee off for 60 seconds, hopefully somewhere between 60 and 120 seconds on this one. And then we'll get back to wrapping this stuff up and then setting up for the questions for next time. I don't know why this is not, it's something that appears fairly obvious to me, is that there is not an absolute time, but that there are bounds on time. That is to say, in the universe, at the densest part of the universe, or at the fastest moving edge of the universe, so to speak, of expansion, or maybe a combination of the two, there is a clock that is the slowest possible ticking clock. That is to say, if you surveyed the entire universe and you checked everybody's watch, and people could actually have stayed at these places and not gotten torn apart by tidal forces and gravity and all that other stuff. If somebody could be there, and you said to them, how old is the universe? There is a minimum number out there, and it's based on the equations of general relativity. There's also a maximum number out there. By the way, the 1377, that's the maximum number. So we talk about there's a minimum number, there's a maximum number out there. So while they are not, there is, you may want to turn around and say, well, the maximum number is the absolute number. Okay, if you want to define that as the absolute number, that's fine. Maybe I don't object to that one. What I will point out, though, is in a general relativistic non-smooth universe, there's only one spot, probably, in the entire universe that is the fastest ticking clock. That the general thing that we use is not entirely accurate. Now, it's almost the same everywhere, but there's probably only one spot. And then there's only one spot where it's the fastest. To me, these are bounds, and all of the math that we do, all the units that we use, ought to be as a ratio from this bound to that bound. And maybe you can say the same about temperature. Temperature is another debate, but ultimately it's some similar idea, that we ought to be talking about the bounds. And when we even measure things, you can't make measurements in this universe unless you're talking about in what direction you're making the measurements relative to these different gravitational bodies and how fast you're moving in them. Length contraction is a thing in these models. And so lengths, your yardstick, if it's sitting on the Earth's surface, your meter stick is so long, and if you get moving through space really, really fast, your meter stick is shorter. So you've got these measurement problems that arise from this model. All that jabbering to basically say this, we ought to be talking about a ratio of shortest to longest and where these things occur from in here. And all of the problems that we have in mathematics, to my mind, are derivative of this idea of trying to fix a universal idealistic norm, absolute, on something that is very clearly not the case. Here's the value of pi of a circle. That's a theoretical circle. It has all these digits because it's infinitely divisible. If it's not infinitely divisible, pi is not that big. In fact, if you want to measure the entire universe, the radius of the entire universe, the circumference of the entire universe, and its ratio to its radius, you only need something like, I don't remember the number, it's less than 20 digits of pi to do that, to within an atom's width. That's how much pi you need. Yet people know thousands and tens of thousands and hundreds of thousands of digits of pi. Who cares? Maybe it's not even a real thing. All right, that's all his fault, if you didn't like that. But at the end of the day, in short, we don't even know. We have problems with our mathematics today that don't work. We have problems in theory. There's a hilarious version, I'll post this one out there, and even our physics theory that someone did to the Bohemian Rhapsody that doesn't make any sense if you're not a physicist. But the guy's basically asking the question of, is any of string theory, he's talking about string theory, is any of string theory right, or is it complete made up nonsense? And this is a student of physics asking this question. And there's a lot of physicists who are like, string theory is absolute garbage. Even some of the popularizers say the same thing.
I just want to congratulate you on your audiovisual support of your argument.
Has it been, yes, please infer whatever you wish from these.
I think where everybody in this classroom is the clock that got pulled out when the universe was the size of the Great Pyramid.
Yeah.
If you look at these objects all moving up the screen at different rates,
Yes.
it depends on where you stand.
So he's got a good point there. And this one, you got to know what your reference point is when you ask the question. And if you don't, Lang's absolutely right. Okay, Peter, and then I'll tie up where we are.
Two quick things. One, who was the scientist that had that? It started with an S, right?
Need more data.
The guy
Who was the scientist that started with an S?
started with the theory you were explaining about time.
I think it's Gerald Schroeder, but let me look it up.
Okay, yeah.
Okay, I'll find it and put it out.
Do you think that in heaven, time is objective or subjective?
Objective. But time is objective here too. Oh man, who just opened that can of worms? Yes, I'm with you on that one. Time is a measure, in my opinion, of change, and change happens over distance. This is all derivative of changes in position. If there are changes of position in heaven, then there is time. If there's causality, there is time. But they may be two names for the same thing. But that's a different topic, and people would really hate you if we started on that one. Okay. I apologize that I don't have the rest of the screen up here, but for the next time, I assume that we want to talk about this a little bit more in some detail. So that was the whole picture to look at. And I didn't mean by the last thing of like, examine your axioms or you don't have any business talking about this. That's not what I meant to say. What I meant to say was, don't get too hubristic on believing that you've got it right unless you've considered the most basic question of all, which is, when I say, not even what is time, which is, yes, that is the most basic question of all, but forget that. Let's say that we agree about time on. Whose time are we talking about? So if you're going to make this old Earth, young Earth argument, you got to know that question as well. Okay, I'll put the rest of this out, but come armed next time with your questions and challenges and hypotheses that you want to test on this particular topic, and let's see if we can't get into a decent friendly argument about this stuff.
I think the question that you're really after is how do you reconcile the evidence with your interpretation of Scripture? And that's been kicked around by the church for 2,000 years.
Yes, and so that's why I like
Different ways of that reconciliation.
that's why I like whether Schroeder's right, if it is Schroeder, whether Schroeder's right about it or not. That just emerged, right? So imagine for a second that Schroeder's viewpoint is right. That when God wrote the Bible, that he so inspired its writing, that what he meant to say was, I used the first clock that was physically possible to work everything up until the point where we got man on the earth, and then I transitioned it to your time so you can understand it. So I used my time up until it was time to hand you the watch, then I handed it your time. This is how it works together. You can't even understand that until Einstein's theory of relativity comes along. Until you understand that model of the universe, nothing that was written back there will make any sense. Let's pretend that that's the case. If that's the case, we weren't even meant to understand how it might work until 1920s.
So once you've made that reconciliation, then you have to ask yourself, so what?
Well, the first question I ask myself is, okay, if that were true, if God said something that wasn't even comprehensible for several thousands of years, but now I've got the data. When you turn around and say, okay, well, now I understand it. The next question should be like, whoa, wait a minute. Is there something else that I might be missing that helps me interpret what this actually means, right? So to that point, that we'll get into next time. All right, thank you all very much for your time and attention. Sorry for the digression into relativity, but some of it's important. If there's anything on this topic that you want, post it on the Facebook page so that we can start talking about it, because that will inform the way that we head next time a little bit too. So if you want to talk about something, please post it. Y'all have a great week, and may your team win of the Super Bowl.